Hello and welcome to the first class. As I mentioned yesterday, the course is focused on teaching you how to use, or the fundamentals at least, of how to use some of the software and systems you're going to be using for most of your classes at UNO or any other engineering department. And the tools we're going to specifically be talking about are Matlab, Python, and Multisim. If I'm hoping we get enough time, we're also going to get into another tool, another software that is called Simulink, which is a sister utility, if you will, that is also owned by the Matlab group. Is another Matlab component. Simulink is really, really powerful because it allows you to do just about anything in terms of simulating any system under very realistic circumstances. Now, just about anything that you can do with Matlab, you can be able to do with Python, okay? Some people prefer more the Python way of doing things. If you're more inclined to programming, to typing, people like command-driven things, then you more likely be using Python more, okay? Matlab, on the other hand, is more visual. There are a lot of tools you can use to create or to automate things a little better. And I think, at least at the beginning, it's easier to just use and implement, okay? But at the end of the day, you can pretty much do the same things that you do with Matlab that you can do with Python, for the purposes you may be looking at. As far as Multisim, and we're going to get to that much later, obviously, you may say that yes, you can pretty much obtain, at the end of the day, you can obtain the same results with Multisim that you will do with Matlab, okay? If you're analyzing an entire system, electronic computer system, yes, you can do it with the Matlab tools, you can do it with the Multisim tools, okay? Now, I'm going to say Multisim is a little more focused, okay? Because Multisim is more circuits-oriented, okay? Whereas Matlab is really more system-oriented. You can, Matlab is not just for electrical engineering applications or electronic applications. It's for a lot more applications, even financial, biology. I mean, a lot of other applications that Multisim is not aiming at, okay? So, but when you combine them, when you can use all of those tools, is a really powerful thing to do. Now, with Multisim, the nice thing about Multisim is that, as you'll see later, if you never used it before, is very visual. I mean, you can actually, it's like really building a circuit virtually. Okay, you actually see the components. You can actually see the devices used to measure current or voltage. You can see meters, scopes, function generators. You can actually see them on the screen and give you a real-time picture of what's going on in the circuit. So, and then again, you can sort of do the same thing in Matlab, but it's a little more complicated in Matlab. In that sense, if you just want to know if you have a circuit, and just want to test it real quick, Multisim is easier, okay? So that's where we're going with all of this, all right? If you use these tools before, then this will be an introduction, especially this first class, where we're going to start talking about Matlab. Is really a basic introduction to what the system is and it does, okay? So it's a really wide overview. As we go into the semester, we're going to be digging into more of the features and things that you can do for more powerful applications. But if you already used Matlab, like we were talking about yesterday or the other day in the lecture, then this will be an introduction, and just bear with us for those of us that, that are new to the system. And eventually we're going to be catching up at the same level. So let me start by sharing my screen. And oops, let's see. Just a minute. Okay, yeah. All right, so this is, again, electrical engineering software tools, and we're going to be talking about Matlab introduction. Specifically, I'm going to be focusing on what is Matlab, how to use it, how the desktop looks like, and what are the main features that you'll see on the desktop in Matlab. Just the fundamentals of the system and what it does, what are variables, and then we're going to dig into vectors and matrices and the use of them. So here we're going to learn just simple Matlab commands, look at the desktop again, learn the basics, just the real basics of scripts, and introduce the use of variables and arrays. So again, Matlab is a high-level language, okay? In actuality, when you create a Matlab script, you save it as an M file, okay, with an M extension, and it has its own way of scripting commands. There's also a way to translate Matlab into C, for example, okay, which is a more advanced feature. If you have an application that uses C, there's a very easy way to translate what you do in Matlab into a C program. So it includes tools that are built in with math functions. They already come ready to use. We don't have to rewrite some of the more specific functions. You can use Matlab for a really wide range of engineering applications, from basic circuit design to signal processing, communications, and so forth. Especially if some of the tools are used. Matlab includes a bunch of tools, okay? Not everyone has the tools because you may not need them. For example, if you're designing, for instance, a communication system, then you can get tools added to the core of Matlab and use them. If you have, for instance, robotic applications, there's certain tools you can use with Matlab. If you have deep learning applications, artificial intelligence applications, there are tools that you can use, okay? We're not going to be looking into those tools, but you'll see that, like many other systems, once you learn the basics of a system, then expanding on its use, it becomes a lot easier, okay? The learning tool for Matlab is not steep. It's really easy to learn. And once you learn it, using the other tools become also very easy to implement, okay? So that's what makes this powerful, that you have Matlab at its core, but you can add blocks, modules, if you will, to the Matlab core to make it a more powerful system, okay? So Matlab, again, is a technical computing system for handling scientific and engineering calculations. And the name Matlab stands for Matrix Laboratory because just about everything that you do in Matlab is based on matrices, okay? It's matrix-based system and can be used interactively. In fact, one of the main uses of Matlab, you can think of Matlab in its more simplistic view as a big calculator. Okay, excuse me. If you look at your scientific calculator, and if you look at the the front of your calculator, obviously, anything that you can do in your calculator, you can do with Matlab real quick. All right, so let's see. So now let's look at the desktop, how it looks like. Excuse me. Hey, sorry about that. Let's start again. So when you look at MATLAB for the first time, this is what you'll see. Okay, you'll normally see this desktop setting here, and some of the panes or windows that you'll see are included in here. An area where you can access your files, so the current folder area, the version, which currently we're using, UNO is 2021, a workspace area where you can see the variables you're working with interactively. And the main area here is your command window. In this area is when you can enter the commands, which are indicated by this prompt, okay? So I would suggest, by the way, there's a way to customize. There's a way to customize this, the setting of the desktop, but I wouldn't recommend it at this point. Okay, I would recommend you keep it by default the way it is, and as you become more used to the system, then you can go into this area called layout, and then you can customize it the way you want. You can move, for instance, if you can move this middle area to the left and this left area to the right, so forth. You can ignore some of the other areas, add some more information with some of the other panes that you can add, and so forth. But at this point, I will suggest you just keep it the way it is, because as you get more used to using it, then it'll become easier for you to get into that. And eventually, we're going to see, what all this menu indicates, okay? But for now, we're going to focus on this area here, where's the desktop, okay? So the windows that you just describe are the command window, which is, again, the main window when you enter variables and you run the programs. The figure window, which may contain any graphics commands. An editor window, which you can use to create scripts, to debug scripts. And that one you enter by any of these icons here. We get into scripts later. Again, this area here is if you want to run anything live, okay? But if you have something that you're using frequently, like a function or anything that you want to run interactively, then you can use scripts, and we can get into that later. And so you can get into the script section, like I said, by just clicking on those icons. There's also a help window, which you can click it at any time to give you any assistance. What else? And then you can have the command history window, the workspace window, and the current folder, which is this one right here, okay? The main operations that you're going to see is like, again, like a calculator, okay? You have a typical addition, subtraction, multiplication, and so forth. But these are the symbols that you will see, which is nothing new, and it's nothing, I mean, it's very intuitive, right? The only one that may be a little bit off will be this left division symbol here, which simply means you're dividing the other way, right? Instead of, if you use the right division, you'll be dividing 5 into 3. if you use the left division, you'll be dividing 3 to 5. Okay, just another way of doing that. And then, of course, exponentiation, which is just the caret symbol here. Okay. Excuse me. Then you have some very useful built-in functions, like the square root, the nth root, if you want to calculate like the third root or whatever of a number, exponential, the absolute value, the log, factorial, and so forth. And there are many of them. These are just some examples of the ones that are built in: sine, cosine, and so forth, tangent. Some of the rounding functions, some of the other functions that you can use, like if you want to return the remainder of a number and so forth. Again, this is pretty much, at this point, you look at this and you say, well, I can do all this in a calculator. And that's correct. This is like a big calculator. But with the advantage that eventually you can use this information to run really powerful scripts, really powerful programs, okay, using some of these functions or some of those commands that we just looked at. So let's take a look. I'm going to stop the sharing for a minute, and we're going to take a look at all right, so let me move to the real system here, to the Matlab. And now you can see the desktop. Okay, this is the real desktop that we were discussing before. So the way that you're going to get to it in your lab is, you're going to have a section when you go in the Matlab, in the computer lab, you're going to have an icon with Matlab in it. If you cannot find it, simply type Matlab on the search and you will see it. Otherwise, you can also go to the virtual desktop, access the virtual desktop, and do the same thing. If it doesn't show under your programs, you can do just a search, Matlab, type Matlab, and it'll show up, and click on it, and it'll bring that up. All right, so I'm going to now look at some of the things you can do, right? By the way, when you want to finish with it, when you're done with it, you can click on this X and and finish your session, or you can either type exit here or quit, and that will close the session. Okay, so you can also, like I said before, under the help, is very useful for especially at the beginning if you want. Because if you click here, it's going to bring you to a website where you can search all kinds of information about how to use Matlab. Like I said before, it can really be used just like a calculator, right? If you type 6 plus 5, for instance, sorry, 6 plus 5, okay, you can see the answer as 11, okay? 45 over 9, the answer is 5, and so forth, okay? If you use the backward slash, like I said, 5 in 10 is dividing 10 into 5, it gives you an answer of 2. Just about anything that you want to do, like you do in a calculator, right? 8 times 9 plus 63, you get that, right? And so forth. So if you want to clear what's on the screen, you can use the CLC command, and CLC will clear the screen, and it'll show you that a clear notebook at that point. Okay. if you miss something, for instance, let's say I'm typing a program where I'm typing a series of commands, and let's just type another few so we can see the what I'm talking about here. Let's say I do 25 divided into 5 plus 8 times 9, okay? And I, look at the result, but then I said, well, that's not what I wanted. I really wanted to do 25 divided into 2, okay? Well, at this point, I don't have to redo everything, okay? If you click on the up arrow, you can see all of the things you've done previously, okay, in that session. So if you keep bringing the arrow up and down, you can get to the specific command that you wanted to correct. So now if I click on that, well, let's go to the previous one. Let's go to this one, for instance, okay? So it's not that obvious. And let's say on that one, I had 8 times 9 plus 63. And let's just say, well, I wanted to have 8 times 7. So you can use the left-hand arrow and go to that point, type 7, and then just run it again. So you can make corrections on the spot very easily, especially if you have a large or a much complicated statement, and all you want to do is just make a little change. Just use the up arrow, and it'll show you all the things you've done. See, like I was starting here, all the things I was doing, and you can select the one that you want to correct or the one that you want to add something to it. That's a very easy thing to do. You can also use the clear CLR command, and that will clear. I'm sorry. I think we're having an issue here. Let's see. I noticed earlier that I'll go back to that some of the scripts were given some kind of error before, so we'll have to look into that. But let me see, everything seems okay now. So anyhow, it also has, Matlab has a very useful editing feature that is called smart recall. For instance, if I just type, if you look at one of the previous statements, right? Like I have 8 times 7 plus 63. If I type 8, and if I do the time 7, right? It'll try, if I have something that I have done before that resembles that statement or that simple math, it'll try to recall it. And so you don't have to retype it again. At this point, I don't have anything significant that I can show, but I will show you that as we go along. Okay, so let's go back now to the slides, and I'm going to show you that area. All right, so let's go back to the slides now and move on to some of the rules that you're going to see about variable names, okay? Some of those rules are kind of obvious. You maybe have already been used to it. If you've done a little programming, you know what those are. But you just got to be careful. They may be a little different from the ones you've been used to using, but just remember to follow these rules. I'm not going to mention all of them, but for example, you must begin a variable with a letter. You cannot begin with a symbol or with a underscore, for instance. Like some programming languages allow you to do that. I start a variable name with an underscore. Well, Matlab, you can't. It's got to be a letter, and it can be up to 63 characters long. You can have letters, digits, and you can include the underscore character, but no punctuation. It's case sensitive also, so capital A and lowercase a are two different variables, okay? Just like in this example, capital AA and capital lowercase a are two distinct variables, okay? That you have to be careful because that could create problems if you don't follow that rule very closely. There's no spaces around between characters. You can always use the underscore. And of course, you avoid, and as much as possible, not to use the built-in functions for a variable. Once a function is named, used for a variable name, the function cannot be used. So in some instances, you get an error. In some instances, you won't get an error. But you just got to be careful of what's already built in. For example, pi, you don't want to use that as your own variable name for obvious reasons. So just be aware of that. There's also some predefined variable and keywords, and these are included here. The ANS variable shows up. If we, for instance, don't assign a value to a variable, then automatically it goes into the answer. Okay, and you'll see that in a minute how that works. Pi, for instance, again, is the number pi. EPS is the smallest difference between two numbers. Is almost zero. As you can see, is this number times to the minus 2 to the minus 52. Okay, this is a really, really small number. But in many instances, is used for applications where you want to know the effect of dividing by zero, but you cannot divide by zero. So you can use EPS as the effective zero, if you will. INF is used for infinity, and the letters I and J are used for imaginary numbers. Now, again, in electrical engineering, of course, we use J for imaginary numbers. So that's why I and J here are used as the imaginary components of a complex number. And NaN stands for not a number. Okay. Some of the other commands, like I said, clear will remove the variables from the memory. Clear XYZ, for instance, remove only the values for those specific variables that you have on the list right here. Okay. So if you have, 20 variables other than XYZ, this command here will keep the other variables, but will remove XYZ out of the list. Okay. Who displays the list of variables that you have in memory, and who's gives you the size of the variables you have in memory. Okay. So let's try some of that. Let me pause the sharing and go back to the again. All right, so let's again go back to our desktop. And let's see, looking back at the, oops. Okay, looking back at the previous statements that I was doing here, see, like I was using this as a calculator, remember? I was trying to use clear before. And yeah, that will do it. I think I mistyped it the first time. That's why I was getting that error. But clear will clear the variables, any variables that you have defined. And at this point, I haven't really defined any variables. I haven't really assigned anything to any variable, right? I've just been using it as a calculator, right? Nothing is really being saved, in other words. But again, you can assign the variables to it. Like if I assign x equals 2, okay, I can end a command. If I end a command like this and I just press return, I will see the value that I just typed on the screen, right? Y equals 55, I will see it. If I type a semicolon at the end, I won't see that. Okay. It's there, but I don't see it. So if I type Y again, I will see it like that, right? So that's a way of avoiding the obvious things that you don't want to just see everything, right? Because then the screen gets very crowded very quickly. So doing that will keep track of what you can see and cannot see. So For instance, again, if I do x equals 7, and I'm going to let them show y equals 9, then you can perform operations on this variable. So now I have a variable x and a variable y, right? Really obvious. One has a number 5, one has a number 7. So I can use those variables to perform, operations again, like with a calculator, right? So I can say x times y will give me this, and y divided by x will give me this, and so forth, right? Now, you notice what I mentioned before about the answer, ANS keyword. It appears if I don't assign a value to the result. So for instance, in these two previous cases, right, when I multiply x times y, when I divided y over x, I did not assign anything to the result. So automatically goes into that answer variable, if you will, ANS. But in the most common case, I'm going to assign, right, a variable to the result. For instance, if I do x times y, but I assign that result to z, okay, then like most computer languages, there's an assignment from right to left, right? The value, the result of multiplying x times y is going to be stored in variable z, okay? Again, I can choose to put a semicolon so I won't see the return, but if I type z, I will then see the result if I don't have a semicolon at the end. Or if I just simply ignore the semicolon in the first place, like this, I will see the result automatically again, right? So, very simple, right? Again, some of the built-in functions, pi, you know what pi is. You can do, let's say we have x equals 45, and I want to compute the sine of 45. Automatically, Matlab looks at the numbers as radians. So if I want to do I want to see the result in degrees, I'm going to divide pi over 80, 180, and I'm going to multiply by, and I'm going to use parentheses just to make sure that, that we keep everything in the right order. And I'm going to multiply that by the value of x, so that I get the sine, the result of the sine, right? So doing that gives me the sine of 45 degrees, right? And again, I haven't assigned it to anything, right? That's why you see the answer, the ANS. But I can go ahead and assign it if I want. I can, again, remember, I can use the up arrow and access any area that I want. So I'm going to assign this value, sine of x, sine of 45, to n, right? N equals that value. Okay. So again, if I do a semicolon, I won't see that result. Then I can always go back and say, well, what was the value of n? If n hasn't changed, it'll have that value of the sine of 45 degrees. Okay. Again, very simple. The other functions that you have, many other functions, like we said before, the log of a number and so forth, and we'll look into that later. All the other functions, tangent and so forth, it's the same thing. You use them in the same fashion. You also have some other built-in functions like date. And we'll show you the day, today's date. You have calendar. It'll show you the month, calendar, and the year, and so forth. There's other ones like that that are useful in many cases. Okay, so like we said before, Matlab makes use of matrices. Okay, it's really built into matrices. And as you remember, when you look at numbers, right? If a number is a scalar, is simply a one-dimensional number, right? If a number is a vector, it could be two-dimensional. It's mostly two-dimensional system. But an array can be multidimensional, right? Now, the difference between a scalar and a vector, if you remember, is that a scalar, again, is just like the magnitude, right? It only has one component, one dimension. A vector has a magnitude and a direction, right? So it's a two-dimensional quantity. And so that's the difference. So a quantity that has magnitude but no particular direction is what we call a scalar. The quantity that has magnitude and acts in a particular direction, we call that a vector. And it could be multi-dimensional, right? Force is a vector, velocity is a vector, and so forth. So the way we define vectors in Matlab is by simply putting it into brackets, okay? So I'm going to create a vector called capital Y, and I'm going to make it equal to different values, and I'm going to use this values just randomly, and I'm going to put it in the brackets, right? So I'm going to space them out 1, 5, 8, 7, 9, right? So that's my vector Y, and I'm going to close it with the brackets. And again, I'm going to keep it open so I can see the result of what I just typed, right? So I'm going to press return. You can see that's my vector, right? Okay, it's a one row vector, right? You can do also, if another option, if you want to write that vector, is to use commas instead of spaces. So if I repeat that Y vector, and I'm going to redefine it now as the same numbers actually, but this time I'm going to use commas instead of spaces. So I have 1, 5, 8, 7, and 9, of course. And I'm going to again just press return, and again I get the same result, obviously. But the point I want to make is that you can create vectors in this way or in this way, using commas or using spaces. The system recognizes either one of those two. Okay. And so the way that later we'll see more complicated examples of how we use arrays and vectors in these examples. But for now, this shows you just the basic way that you can create a vector, right, in the system. You notice here that we haven't defined what type of number we have in the system, or whether it's whether we want integers or real or any other size of the number or anything. Later we'll see how you can define how you want to define what you want to include in those vectors, the actual numbers. Also, another thing is that you'll see that if I in this case, the vectors are always defined with the rows, the rows first. So this is a one row system with 5 columns. So it's a 1 by 5. Okay. So a 1 by 5 system. Okay. We'll see later how we can manipulate the different columns and the different rows. But that's the basic idea behind just defining those vectors. You can also put several commands on the same line, okay? I don't have to, like I've been doing here, doing one line per command. I can put several commands in the same line, but just separating the items by commas. For example, here I'm gonna let me just change the value of Y, right? Instead of having 1587, I'm gonna have 156, and I'm gonna add another number 12, right? So that's my new Y. But I also want to define a value for a vector X, and I'm gonna put that in the sorry. So I'm going to create X as the new vector with numbers, I don't know, 5, 7, 3, 8, and 12. Okay. And I can continue if I wanted to, right? I can put commas, and then I'm going to create another vector called R equals 1 and 25. And so at that point, see, I didn't have to do one line at a time. I can use one single line to create as many variables as I want. Now, this may not seem important at this point, but it's really useful when you're doing scripts, when you're using functions, right? Because I can use this to create scripts that run by themselves, and it can make it more readable, and it can make it easier to write when you have larger scripts. So I'm going to type semicolon at the end, so I don't see the result. Well, I didn't do it enough, because what happens here is that it only ignores the last one. Okay, see, R didn't show up, right? But if I type R again, it'll show me the values that I put in for R. Okay, so what it did was it created those three vectors. Now I put a semicolon at the end, and what it did was it just ignored the last one. It didn't ignore the other two. Another thing that that you can see also in here is that I can go back and change those numbers, right? Again, if I use my up arrow, see how easy it is not to get to that point where if everything is in one line, I can easily go back and change any of the numbers, right? Any of the numbers in the vectors inside. So if I want to change that 5 into a, for instance, a 3, now I don't have to redo everything and go back line by line. I can just go back to that particular line and change the value for X. Also notice one thing that we talked about before about the variables, right? I define the name of the variables. I define R as 125. It's a 1x2 vector, 1 row, 2 columns, right? So let's say I want to know what I want to square R, right? So I can do R to the second, right? Press return, and you can see that you get an error, right? And the reason for that is because now this is a vector, okay? And with a vector, you got to use a period previous to the operator that you have. For instance, if I have R period caret 2, okay, now I can square that vector. Now the difference is, let me go back to that. Let's say you have a number, a scalar number, right? X, let me go back to, I think I still have my X. Let's see. Yeah, X is 45, right? Now, X is a scalar. So with X, it's not a problem if I do X squared, right? And it gives me the square of the number because it is a scalar, right? But if it is a vector, if I do vector operations, if I do any of the vector, any operation, I have to use a period or a dot before the operation. So going back to our vectors, right? I have X and Y, for instance. Say I want to raise X to the third power, right? Again, if I want to raise X, the vector X to the third power, I'm going to need a period before the caret, and then I'm going to see the result of every element in X raised to the third power. Now notice if I do this too, if I say X dot or period to the 3, see what happens. Notice what happened here. It took the value of, not the value of the vector, but the value of the variable that I had before. That's why they only raised that variable by itself. because, like we mentioned before, lowercase x and uppercase x are different, okay? They're totally different in the system. For instance, if I type lowercase r, it gives me an error, right? Because I haven't defined yet a lowercase r. I define an uppercase r, and the system is smart enough to tell me, hey, did you mean uppercase r? Because that's what I have in memory. I don't have a lowercase r, okay? So it's important, right? Lowercase, uppercase is really important. All right. So let's see. So let's go back now to slides and continue in that area. And I'm going to go back to my presentation here. And let's share that. Okay. So hopefully we're sharing now the PowerPoint. Okay, so now you probably understand now what we meant by having the variable names, uppercase, lowercase. There's a difference between the two. Let's do one example here. Let's try to do something a little more complicated, right? So we have that number, the square root of that quantity inside, and we're going to then add e to the 3.5 power. Okay, so how we can do something like that in Matlab is really very easy. The only thing you got to be careful about is, again, try to keep track of the different operations and the precedence, right? You always know the multiplication and division are the more powerful of the two of the operations. And so the idea is that, always use parentheses as much as possible so you can keep things under control, okay? So let's go back now. Okay, so we have that operation we want to do. So let's go to our Matlab environment and then resolve it. So this is the operation we were talking about, right? This is what we want to do. So I'm going to, I already typed it in, so I'm going to just bring it in. Let's see, I'll bring it. Okay, didn't save it, so let's do it again. Is the square root of this, the cubic root of 80 plus 80 over 2.6. So I'm going to use parentheses for this, and the key when applying this rather simple problems of doing arithmetic or any kind of math is to be careful with the operations and to make use of parentheses as much as you want. So I'm going to have I have it right here typed in. Okay, so I'm going to have 8, right, plus 80 over 2.6, all of that raised to the that should be 1/3, right? Because I'm taking the third the square, the cubic root, right? The 1/3. That's better. And then I'm going to add to that result, I'm going to add the exponential to the 3.5, raised to the 3.5. Notice here that for the exponential function, I don't need an extra caret, okay, because the function understands that it's going to take that number as the exponential. That is e to the 3.5 and I don't need the caret as I do here. Okay, so computing that gives me the answer that I was looking for. Okay, so again, notice how um, this is then just implemented using by the proper use of parentheses. Okay. All right. Let's do some other examples. So, and what I would suggest is that you pause the video. Okay, I'm gonna pause the question, if you will, and then you do um, and then you do try to do them yourselves. Now, one thing that I want to remind you of is we talked about the who and the who as commands, right? Remember the who tells you what variables I have in memory. Okay, and so far I use all these variables. I've defined all those variables, right? For different things that we've done. If I do who s, it'll give me the size um, of each variable in terms of bytes, right? How many bytes each one is taking in memory. You may not think this is important at this point, but later you'll see that in many cases you need to be aware of the sizes, okay? And it's something that you need to extract maybe from some section in your program. So this will be a good tool that you can use later to see where you are in terms of memory size. What was the other one we discussed? Let's see, who has we talked about clear already, and we talked about the different functions. And let's see. Okay, so try to use yourself, okay? Try to use Matlab and hold on, let's see. To implement this, okay? I'm going to show you something on the screen. Just a second. Okay, I want you to evaluate this function here when x is equal to pi over 5. Okay, so I want you to evaluate this function when x is equal to pi over 5. That's your task. So you can pause the video. I'm gonna just show you the solution, but I suggest you pause it, try to do it, and see what you can come up with. Okay. So here we are. All right, and that's my solution, right? So you have tangent x, right? And again, use of parentheses, right? Now, if I do this right away, okay, see, it's going to take whatever value of x I had before. Right? I haven't redefined x, so it's going to take the value of x that I previously have. So before I do this, I can do it on the same line, actually. I'm going to define x as pi over 5. And then I can run this. Okay, so if I run this, it's going to give me the answer I'm looking for. So for x equals pi over 5, which is this number 0.6283, the answer will be 0.9045. Okay, so hopefully you got that. All right, so try this one now. And again, I'm going to show you on the screen. And I'm going to ask you to do it yourself. Okay. Try entering and getting the result for that for this operation. Again, you can pause the video, right? Pause the video, and I'm going to show you the solution. And then it's just a quick exercise, right? Nothing fancy, but just kind of getting used to, some of the rules that we discussed. So this is the solution, right? I have some extra information there that I don't need. Okay, so so that's it, right? So this here, see, oops, there we go. This here is implemented by this statement here. Okay, again, it's all a matter of using the parentheses the right way. So when I click return, I get that as the answer. Okay. Let's try one more on the same fashion. I'm going to clear some of this clutter and try this one now on your own. Okay, try this one here. Okay, again, you can pause the video and I'm going to show you the solution. Just a minute here. All right, so that's the solution for this little problem here, right? That's how you implement it. First return, and you should be, oops, something you didn't like. Oh, I have an extra, it looks like I have an extra parenthesis. Oh, good. All right. So I'm going to go back to my commands here, and I'm going to go and fix that parenthesis. And let's see, looks like everything is okay now. For some reason, that extra parenthesis got in there, but okay, that should be the answer. Okay. And so it's a good thing because you see, it actually indicated me where the problem might be. See, it pointed right there where the extra parenthesis was. Now, it doesn't always tell you exactly where the error might be, but in many cases, like in this case, it tells you exactly where the problem is, and that's a good thing, right? It's very intuitive. And that's another thing that, especially if you run it in the command mode, that Python is not going to tell you directly, where the exact problem might be. Okay? Matlab, in many cases, will tell you where the problem might be. Okay, it's a little more user friendly. All right, let's try some other ones that you can do on your own. Let's try one more. Okay, and I'm going to give you this one, and again, I'm going to give you some time to actually try to resolve it. More of the type of problems you may have, a little more challenging, if you will, to try to use Matlab for this. So we have the volume of a cylinder of height h and radius r is given by this formula, right? The volume, is pi times r squared times the height. And it says a particular cylindrical tank is 15 meters tall and it has a radius of 8 meters. We want to construct another cylindrical tank with a volume 20% greater but having the same height. How large must the radius be? Okay. So I'm gonna show you the answer, but if you wanna just pause the video again, I would encourage you to just try to solve it, right? On your own first. Okay. So all right, so hopefully you pause the video, you solve it, and then you have the answer. But the first thing you should do is you're looking for the radius, is to solve for the radius, right? So when you solve for the radius, you should get an equation that looks somewhat like this. I know it's going to be kind of small here, but oh no, you can see it, right? So you're solving for the radius, right? From the equation, the original equation from the volume. So all we gotta do is find the new value for R, and then add 20% to it, right? So I'm gonna, again, R is equal to 8, right? The height is equal to 15. And then the volume is pi times R squared times H, right? Okay. And then I'm going to solve for R, right? So that gives me the volume, given that value of R that I was given before. But the new volume of, or rather, this gives me the equation, for finding the volume. But the new volume that I want is going to be 0.2% more. So the new V is going to be equal to the old V plus 0.2 V, right? To compensate for that percentage that we said. So now I can solve for R with the new value for V. Oops, it wasn't quite ready yet. And then I have R, then the equation that I just showed you previously will be V divided by pi times, let me use some parentheses here so I don't mess it up. It's V divided by pi times H, and that raised to the 1/2, because it's taking the square root. And that should give me the new, oh, okay, let's see, where is the, oh, I have an extra parentheses again, see? The good thing. I don't need a parenthesis at the beginning. So now I have the radius, okay? So let's review this. I think it's okay. It's R equals 8, H is equals 15, V is equal to pi times R square times H. The new volume is going to be, the volume is given by pi times R squared times H. The new volume is going to be equal to V plus 0.20. See, there's a missing operator here, okay? Again, Matlab is telling us that. So let me correct that. So that's a good thing, right? We can go back and correct it. I can go back here, and it's actually telling me what the correct thing should do, right? So now I can rerun rather the equation for R. And again, the nice thing, as you notice, is I don't have to retype anything, right? I can just go back and do it. And that gives me a new value R. Let's again check that out. So V is equal to V plus 0.2 V, which is this value, and then R is going to be equal to V over pi times H raised to the 1/2. Let me, and I think we have another problem here because this one should be in parentheses between the V and the end of the H. So let's correct that. So this shows you, how you can make corrections on the spot without having to change everything at once. So I think that's it. So finally, I think we got the right answer. Okay, but practice with it. I think that that's going to help you just get familiar with the different rules and the innuendos of how the MATLAB system operates. Next time, we're going to be focusing more into the use of matrices and more use of vectors. I think there's one thing I wanted to show you, and that is some of the other functions that you can use in Matlab. For example, if you have a very complicated equation, let's say you have, let's say you want to solve an equation that looks like this, right? I'll give you that equation. Just a minute. All right, so we have a third order equation here, right? So we have three roots that we're looking for. And so this wouldn't be easy to solve manually, obviously, right? And even if you have more than that, it becomes more difficult. But in MATLAB, there's a function called roots. And if I just define the coefficients for each of those terms in a vector and then use the roots function, I can quickly get the result. And I'll show you the example. So in this case, the coefficients for each of the terms will be 1, right? In order of, from highest to lowest in order. It'll be 1, 7, -7, and 40, and -34, right? X to the third, X to the second, X to the 1, X to the 0, right? So again, it'll be a vector that has components 1, -7, 40, and -34. So I can call that vector anything I want. I'm going to call it A, and I'm going to define it again as 1, -7, 40, and -34. Okay, and I'm going to use the same line to compute it. So I'm going to just say roots, and I'm going to use the function roots. And that function is going to find the roots of the polynomial that I just enter with the coefficients, right? So if I do that, I can see the three roots that I get, right? So there's three roots, and the three are imaginary. And you can see now how you have an imaginary number, right? Showing you here a complex number with imaginary components, right? So roots is a really, really very useful function for solving some of these more complicated problems. Okay. Again, we'll continue with this next time. Practice a little more. There's no way that we can go over everything in the class, right? So it's up to you to practice. Just do as many as you can of this different exercises. Try to do mismatches like I did here. I didn't do it on purpose, but try to do things in purpose that can give you an error. And that's a good way for you to find out how MATLAB can really, how smart MATLAB is, right? How can it correct you? See here, it corrected me twice, right? And it really pinpointed to where the correction should be. So that's a good thing, right? And so that helps you along the way. Okay, guys. So I'll see you next time.